Dear student, in previous session, I was explained regarding the Mason's-Gain formula, which is widely useful to find the overall gain or transfer function of the system represented in the form of signal flow graph. Today class, I'm going to explain you how to calculate the overall gain or transfer function of the given system in the form of signal flow graph. Here, need to calculate C of S divided by R of S. The first step, is write the Mason's-Gain formula. Already familiar with the Mason's-Gain formula explained in the previous session. By using Mason's-Gain formula, the overall gain or transfer function C of S divided by R of S is equal to 1 over delta summation of Pk into delta K. In some book, they are using Tk into delta K. You can use any convention, Pk or T letters or P letters, where K is equal to number of year. The K denotes the number of forward paths in the graph, in the flow. In this particular signal flow, there are 2 forward paths. Therefore, I have written 2 here. Therefore, the T of S is equal to C of S divided by R of S is equal to 1 over delta. K is equal to 2. Therefore, K takes 1 and 2. Therefore, K into delta K. 1 by delta is equal to P1 into delta 1. For removing the summation, the P1 into delta 1 plus P2 into delta 2. Here, the this P1 and P2 are the gains of the forward paths. There are 2 forward paths. I have mentioned 2 forward paths in this particular graph. Therefore, the P1 and P2, this P1 is the gains of the first forward path. P2 is the gain of the second forward path. Therefore, the delta, what is this delta? The delta is called as a determinant of the graph. This is the standard relation formula. Delta is equal to 1 minus sum of individual loop gains plus sum of gains product of all possible combinations of the 2 non-touching loops. The first step is over. After writing the formula, next step we need to calculate it. What is the next steps? We need to calculate what is P1, what is the value of P2, what is delta 1, delta 2, and this delta. We need to calculate these things. In order to calculate P1 and P2, we go for identify the number of forward path. Identify the number of forward path from this particular graph. There are 2 forward paths. I have mentioned there are 2 forward paths in this particular signal flow graph. The first forward path starts from R node, ends at the CF node. Any forward path starts from the input node, ends at the output node without crossing any node more than once. That is the standard definitions. In the examination, you will also get a definitions also. They will ask you to what is forward path, what is forward path gain, so closed loop, so transmittance, so branch, so these things I will get a questions in the examination also. You have to go through the previous lectures. I have to go through the previous class notes or my videos, watch my videos for those things. Here, the forward path means starts from there are 2 forward paths. In this particular, the first forward path starts from the R node and ends at the C of S output node without crossing any node. Before that, I'm going to name these nodes as E1 node, E2 node, naming the nodes just for convenience. E4, E3, E4, E5, E6. These are the nodes. I am naming the nodes just for convenience. Next step, after writing the formula, next step is to calculate forward path gains. P1, there are 2 forward paths. We need to calculate the 2 forward path gain. P1 and P2 need to calculate. And also sum of individual gains we need to calculate. And also sum of gains product of the all possible loops need to calculate. After calculating these things, we need to substitute these values. And then you will get the delta value. and then you have to substitute the delta value and delta 1 value, P1 value, then you will get the overall gain of the system. In order to calculate the P1 and P2, I'm going for calculating next step, go for calculating the P1 and P2 are the gains of the forward pass first and second. Therefore, next step second, step second, step second. In next step, I'm going to calculate the step second gains of the forward pass. The second step is to identify the forward path. I have identified the forward path. There are two forward paths. From the identification of the after identification, we need to calculate the gains of the forward path. The gains of the forward path can be denoted by P1 and P2 with the gains of the forward path P1 and P2 respectively. Therefore, gain of the forward path 1, P1 is equal to the gains of the forward path means is a product of the branch transmittance or gains of the forward path. The gains product. The forward path gain is nothing but the product of the gains of the branches of the forward path. Therefore, we need to the gain of the forward path first is denoted by P1. P1 is equal to 1 into G1 into G2 into G3 into G4 into G5. That is the gain of the first forward path. Similarly, gain of the forward path second, the forward path second start from input node, insert the output node without crossing any node more than once. Therefore, starts from R node, goes to the E1 node via the G6. This is the G6. This is the second forward path. I have written the diagram also. This is the second forward path via the G6, G6, and E4, E5, E6. These are the gains. We need to multiply 1 into G6 into we need to G6 into G4 into G5. That is the G6, G4, G4, G5, G6 is the gain of the second forward path. This is the way. After finding the number of forward from the graph, we need to find out the forward path gains. If forward paths are 2, k is equal to 2, then we need to calculate 3 forward paths gains. If it is 3, we need to calculate. But identification of the forward path is very important. The forward path means the forward path andre input node ಇಂದ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ, ಔಟ್ಪುಟ್ ನೋಡ್ ಅಲ್ಲಿ ಎಂಡ್ ಆಗುತ್ತೆ. ಮೋರ್ ದ್ಯಾನ್ ಎನಿ ನೋಡ್ ಓನ್ಲಿ ಒನ್ಸ್ ಮಾತ್ರ ಪಾಸ್ ಆಗಬೇಕು, ಅದನ್ನ ಫಾರ್ವರ್ಡ್ ಪಾತ್ ಅಂತ ಕರೀತಾರೆ. ಬಟ್ ಬ್ರಾಂಚ್ ವೈಲ್ ಮೂವಿಂಗ್ the sign of the branches must be same, direction must be same, branch directions same ಇರಬೇಕು. This is first forward path, this is the second forward path, and this is suppose R E1 E2 ಮತ್ತೆ E2 E3 ಬಂದು ಮತ್ತೆ ಹಿಂಗ್ ಬಂದು ಮತ್ತೆ ಹಿಂಗ್ ಹೋಗಿಲ್ಲ. that is the crossing the E2 node 2 times, 3 node 2 times. So this is not a forward for first path, another forward path, and also this is not a forward path because the direction is opposite. ಇದಕ್ಕೆ opposite ಆಗಿದೆ. Wherever this is not a forward path. This is also not a forward path because branch directions opposite ಇದೆ. ಇದು ಮಾತ್ರ in this same directions ಅಲ್ಲಿ ಬರುತ್ತೆ. That is for identification of the forward path is very important. Okay, first identify the forward path, that is gives the k value. The forward path gains means k is equal to 2. There are 2 forward paths. We need to calculate those forward path gains. What is forward path gains? Is a multiplication or product of the branch transmittance. In branch irutta the branches the gains, one another gain G1 G2 G3 gains of the branches ಅಂತ ಕರೀತಾರೆ. ಅವನ್ನೆಲ್ಲ ಮಲ್ಟಿಪ್ಲೈಡ್ ಮಾಡಿ ಇದನ್ನೇ ಫಾರ್ವರ್ಡ್ ಪಾತ್ ಗೇನ್ಸ್ ಅಂತ ಕರೀತಾರೆ. In next step I'm going to explain next is a individual loop gains because we need to calculate the delta ದಲ್ಲಿ individual loop gains ಇದೆ. and also gains product of the two non-touching combinations. There are two terms we need to calculate. Next step, we need to calculate the loops gains, loop gains, that is the individual loop gains. In step 3, go for calculating the individual loop gains. Individual loop gain. In order to calculate individual loop gains, we need to identify the number of loops in the signal flow graph. How many loops? Loops means it is a closed path. Starting start at ends at the same point, same nodes. Start at ends at the same node. This is the loop. See, this is the one loop. Starts at the E2 node, goes to the E3 node via the minus H1. And also, second loop is E2 node, starts from the E3, goes to the E3 node, E4 node, starts at ends at the same node. Loop is a closed path. And these terms will be getting in the examination also, explain the closed path. Therefore, closed path is a means starts at ends at the same node. Or loop. Closed path is also called as a loop, starts at ends at the same node. Here go to the E3 node, E4 node, via the minus H2 comes to the same node. This is the second loop. And another third loop is here, L3 loop. This is L3. This is L1. This is L2. These are the loops. Therefore, after identification of the loops, we need to calculate the loop gains. Loop gains means is a product of the branch of the loops. Product of branch gains. The gain G2 is the gain, minus H1 is the gain. We need to multiply. So I have mentioned at P11, P22, P33. I have mentioned that P11 is a symbol for loop gain of this L1. Therefore, P11 is equal to product G2 into minus H1. This is the value. Similarly, loop gain 2 is sent at P22. Therefore, here product G2 into G3 into this branch. Therefore, this is the value. Similarly, this into this branch transmittance value. This is the P3. Can use any convention P11 or P22 or L1. L1 is equal to L1 called as a loop gain. Some bug uses the L1 also loop gain. L1 is a gain of the loop 1. L2 is a loop gain. I have assumed P11 is the gain of the loop 1. P22 is the gain of the loop 2. P33 is the loop gains. You can use any convention, no problem. But your identification of loop from the graph is very important. But this is not a loop. Starts from the goes to this node because branch is opposite. Loops andre ಒಂದೇ ನೋಡಲ್ ಸ್ಟಾರ್ಟ್ ಆಗಬೇಕು ಅದೇ ನೋಡಲ್ ಎಂಡ್ ಆಗಬೇಕು. ಬಟ್ ಆಫ್ಟರ್ ಪಾಸಿಂಗ್ ಥ್ರೂ ದಿಸ್ ಸರ್ಟನ್ ಪಾರ್ಟ್ ಆಫ್ ದಿ ಗ್ರಾಫ್ ಸೇಮ್ ನೋಡಿಗೆ ಬರಬೇಕು. ಬರ್ಬೇಕಾದ್ರೆ ಬ್ರಾಂಚ್ ಡೈರೆಕ್ಷನ್ ಸೇಮ್ ಇರಬೇಕು. ಹಿಂಗ್ ಹೋಗ್ಬಿಟ್ಟು ಹಿಂಗ್ ಬರೋದ್ ಬಂದಾಗ ಇಲ್ಲಿ ಅಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ಬರುತ್ತೆ. ಬ್ರಾಂಚ್ ಆರೋ ಡೈರೆಕ್ಷನ್ ಮಸ್ಟ್ ಬಿ ಸೇಮ್. Okay, this is not a loop. And also ಇದನ್ನು ಲೂಪ್ ಅನ್ನೋದಕ್ಕೆ ಬರಲ್ಲ, ಯಾಕೆಂದ್ರೆ ಈ ತರ ಬರುತ್ತೆ ಒಂದು ಈಗ ಹೋಗ್ಬಿಟ್ಟು ಹಿಂಗ್ ಬರಬೇಕು. That is not a loop. That is also not a loop. So identification is also very important while calculating the transfer function using the Mason's gain formula. Okay, loops and identification ಮಾಡೋದು wrong ಆದರೆ I will get a wrong delta value is wrong. That is what identify the proper way. You have to identify one or two, three times. We have to verify how many loops are present without confusion. That is what you have to work more examples. You have to go work you have to work on the more example until you're familiar with this particular concept. I'm going to next step. I'm going to explain you calculate the individual loop. After calculating individual loop, we need to calculate the gains, sum of gains product of the non-touching loops. Need to find out the gains product of the non-touching loops. I'm going to explain in step 4. In step 4, we go for calculating the gains product of two non-touching loops. Gains product of the two non-touching loops. Here there are two combinations. We need to calculate the gains product of the non-touching two non-touching loops. So we need to identify how many combinations non-touching loop combination. We need to identify the non-touching loop combinations. Non-touching L1 and L3 are the non-touching, and L3 is non-touching. The first combinations of non-touching loops are L1 and L2. The loops are said to be non-touching that does not contains the common node. Common node illa andre ಅದನ್ನ ಎರಡು ಲೂಪ್ಗೂ ಕಾಮನ್ ನೋಡ್ಸ್ ಇದ್ರೆ ಅದನ್ನ ಟಚಿಂಗ್ ಲೂಪ್ಸ್ ಅಂತ ಕರೀತಾರೆ. If the two loops does not have the common nodes, so common nodes, so ಎರಡು loops common nodes illa andre, then they are said to be non-touching loops. So here nodi L2, L1 and L3 having the common node E2 and E3, they are called as the touching loops. Similarly, L1 and L3 are the non-touching loops. L1 and L3 are the non-touching loops because contain. Similarly, L2 is also not touching to the L3. From the signal flow graph, identify the non-touching loop combinations. Here, how many combinations? There are two combinations of non-touching loops. Let P13, P1 andre corresponding to L13 and corresponding to P13 is the gain of the 1 and 2, 1 and 3 gains product. Similarly, P23, P2, 2 corresponding loop to is a 3 is the gain of the 3. The P is a letter for indicating the gain. P23 gains the gains product of the two non-touching loops. Therefore, the first combinations of non-touching loops are L1 and L3. Therefore, this is denoted by P13. Therefore, P13 in the P13 is a product of P11 and P22. P22 similarly is a product. So similarly, P22 is equal to P23 is equal to P22 into P33. It's a gains product of the loop for second and third. Therefore, this is the gain of the gains product of the two non-touching combinations. After calculating gains product of the, we have to substitute this in delta, determinant of the graph. Delta, what is delta? Delta is equal to 1 minus sum of individual loop gains plus gains per sum of gains. We need to add this. This is the gains multiplication. This is the L1 loop gain and this is the L2 loop gain. We need to multiply. We'll get an answer. Minus into minus plus. Therefore, G2, G5, H1 and H2. Similarly, here also we need to multiply. This is the two loop gains product. This is the P23 is also 1 and 3 loop gains product. You have to substitute in the delta. Delta is equal to 1 minus sum of individual loop gains plus. There we need to substitute, then we will get the delta. The next step is to calculate the delta, determinant of the graph and delta k. In step 5, we go for calculating the determinant of the graph. The determinant of the graph is denoted by delta, and also we need to calculate the delta k. Therefore, we know that the delta formula, we know that delta is equal to 1 minus sum of individual loop gains plus sum of gains product of two non-touching loops. Sum of gains product is already calculated. Individual loop calculated loop gains in step 1, step 2. Therefore, we need to substitute. Individual loop gains are denoted by P11, P22, P33 value calculated, and also they are calculated. Sum of gains product of the two non-touching loops are calculated, P13 and P23. You substitute here 1 minus G2, and this is the value because loop gains. Sum of P11 value is this, and P22 value is this, P3 value is this. Therefore, minus after taking the minus outside and multiplication, this is become positive, and also this P11 value and this is the P13 value and P23 value. This is P13 value, P23 value. This is the delta. After calculating individual loop gains, we have substitute here, and also we want to gain sum of the gains. Not to calculate this gains product calculated in previous step. Also substitute here. This gives the delta. Now, how to calculate the delta k is very important. I'm going to explain in next step. I'm going to calculation of next step is to calculate the delta k. Calculation of delta k is very important in signal flow graph. Here there are two forward paths. Therefore, k is equal to x1 and 2. Therefore, we need to calculate delta 1 and delta 2 because there are two forward paths. If there is a three forward paths, we need to calculate delta 1, delta 2, delta. There are six forward paths, then we need to calculate delta 1, delta 2, delta 3. Likewise, we need to calculate. But here there are two forward paths. Therefore, k is equal to 1 and 2. Here k is equal to 1. Then delta k. Therefore, delta 1 is equal to 1. Here, what is the delta k? Is also delta k is also delta. It's a part of the graph which is not touching to the first forward path, second forward path. The delta k can be calculated in the similar way of calculating the delta, but part of the graph which is not touching to the first forward path and second forward path. Now consider the first forward path. Consider the delta 1b can be calculated by considering the first forward path. Similarly, say delta 2 can be calculated by considering the second forward path. Therefore, this is delta 1 is equal to 1. I have written because here delta 1 is equal to 1 because for the first forward path, consider the first forward path. Here, this is the first forward path. For this first forward path, there is no part of the since there is no part of the graph not touching to the first forward path. There is no part of the graph because all the part of the graph is touching to the first forward path. Therefore, delta 1 is equal to delta. What is the delta value? 1 minus sum, 1 minus 0. Here the 1 minus 0, 1 minus sum of individual loop is 0 and other term is 0. Therefore, we go for writing delta 1 is equal to 1. Similarly, delta 2 is equal to can be calculated by considering the second forward path. Can be considered by the second forward path. Here, this is the second forward path. Therefore, which is the part of the graph which is not touching to the second forward path? Now, this is the second forward path. This is the second forward path. Now, what is the value of second forward path? The part of the graph which is not touching to the second forward path. This is the part. This is the graph, second forward path. If I remove these branches, then automatically this is this part of the graph which is not touching. For this particular graph, applies the delta formula. What is the delta? Delta is equal to 1 minus sum of, that is the formula. Delta is equal to delta. What is delta? Delta is equal to 1 minus sum of individual loop gains. Here there is a loop. Therefore, the loop gain is minus G2 into H1. That is, I have written delta 2 value is equal to this value 1 plus G2 into H1. Therefore, delta 1 is calculated, delta 2 is calculated. Now, these values, delta 1 or delta 2, and also P1, P2, to substitute in Mason's gain formula, then we will get the overall gain step. Next step is to calculate overall gain by substituting these values for calculating the overall gain. You have to understand the calculation of delta k is very important. When you go for solving the more number of examples, then you can easily understand it. In order to understanding the concept, the best way means to solve the more example. Then only you can understand the concept. Otherwise, difficult to follow. Try to solve more example. You have to go through my class notes. I have clearly written my class notes also. Last step is to calculate the transfer functions. Once we calculate the delta and delta 1 or delta 2, P1 or P2, then we go for substituting these values in the formula. Already written in the first step, also already written this formula. Now, what is T of S is denotes the transfer function. T of S is a convention used for indicating the transfer function. The C of S, Laplace transform of the output to the input, is equal to 1 over delta P1 into delta 1 plus P2 into delta 2. This is the formula returning step 1. Therefore, we recalculated in this value, P1 delta 1 value, delta 2 value, and also for first forward path gain, first forward or second forward path gain, these values to substitute, then you will get the overall gain of the system. This is the these are the steps involved in calculating the transfer function of the given system represented in the form of signal flow graph by using Mason's gain formula. The signal flow graph, if the control system represented in the form of signal flow graph, then we can use the Mason's gain formula uh, to calculate the overall gain or transfer function of the system. In next sessions, I'm going to solve more examples. Thank you for listening.